We are live now. We are live. We are live. We are live, my dear friend. So first, do tell me the quality of the broadcast. Quality of the broadcast. You can rate it from between 1 to 10. You can rate it in between 1 to 10. If I'm audible and you can see the video well, then you can rate it 10, 9, 8, 7, 6, the way you want. And if the audio is not audible, okay, if the audio is not audible, and if the video that you are watching is lagging or kind of something, that you can rate it low. 1, 2, 3, 4, it depends, okay, on the quality of the broadcast. 2 for 10 for the best, and 1 for the what, for the bad, okay, for the bad quality. You can rate it between 1 to 10. It's on you. After this, do tell me the quality of the broadcast. Okay, you have told me the quality of the broadcast. Do tell me how's the preparation for the exam is going on. How's the preparation for the exam is going on? If it is going Ayushi Verma 7, okay, not bad, not bad, not bad. And the preparation of the exam, how's the preparation of the exam going on? If it is going bad, then rate it 1. And if it is going okay, I mean, if it is going okay, then you can rate it 2. And if it is going very good, excellent, then you can rate it 3. 1, 2, 3. 1 for the bad, 2 for the okay, and 3 for the very good kind of preparation that you are having. 1, 2, 3. And if you are in this field, then everything is fine for you. But if you are in this category of the 1 or 2, then we have a plan for you. We have a plan for you. What you have to do? You have to go to the site Altedemy, and there you can apply a code NEET PHY30. NEET PHY30, where you can have the plan that usually costs 3299 will cost you what? 299. Straightforward 3000 discount you will have. Straightforward 3000 rupees discount you will have if you apply the promo code NEET PHY30. NEET PHY30. Straightforward 3000 rupees discount. After this, today we are going to start the topic electromagnetic inductions, in which our first topic is Faraday's law, in which we will study induced EMF, induced current, and induced charge. These things we are gonna do today, right now, right here. This is what we are going to do today. Faraday's law, induced EMF, current, and charge. First topic in electromagnetic induction. Then something about me, a little introduction about me. Myself, Raghav Sharma, as you know, my name. This person that is standing is me. The person that is standing, okay, like this, is me. I have 3+ years of teaching experience, MSc Physics, BSc Physics, B.Ed, published an article in JACS, and has done some research work in JNU that was published in this journal. Okay. So this is about me. My little introduction, that you should know that who is teaching you. After this, this is going to be, this is what is going to be our goal for today. Our goal for today. This is what we are going to do today. We will do magnetic flux, Faraday's experiment, Faraday law of electromagnetic induction, and how flux can change, how the flux can change induced charge, and we are gonna do the question time. In question time, we are going to do what? We are going to do the previous year question. Previous year question that we will do in question time. Previous year questions. Okay, previous year questions are important. Okay, sometimes they repeat, and sometimes similar questions do what? Do come. Similar questions do come. So this is what we are going to do today. Magnetic flux, Faraday experiment, Faraday's laws, how flux can change, induced charge, what is the induced charge in the current in the loop. This are all the things that we are going to do today. After this, make sure you have subscribed to our channel on the NEET. Make sure you had subscribed our channel on NEET, where we provide what? PDF materials, free classes, do various announcements, and give you discounts and prizes. Yes, discounts and prizes. My dear friend, you can also get our paid plan absolutely free, and some student have already get that plan absolutely free. So we kind of do these things, and we also do giveaways, give hefty discounts, also do prizes. Prizes, you can say prizes or you can say giveaways. The way you want to say, it's on you. Absolutely on you, the way you want to say it. The way you want to say it. Now let's start our topic, electromagnetic induction. Electromagnetic induction. Before starting that, what is electromagnetic induction? What is EMI? Electromagnetic induction. You should know what is magnetic flux. What is magnetic flux? You should know what is magnetic flux. Magnetic flux. So magnetic flux through any conductor. Okay. Through any conductor, or you can say any loop. You can say any loop, or any conductor. Okay, any loop, any conductor is first of all is directly proportional to the what? Is directly proportional to the magnetic field. Is directly proportional to the what? Magnetic field. Magnetic flux. Magnetic flux is given by this symbol, phi symbol. Magnetic flux is given by phi symbol. So first thing, that magnetic flux is directly proportional to the what? Directly proportional to the magnetic field. Magnetic field. You know magnetic field. You can show the strength of the magnetic field by what? By the magnetic field lines. You can show the strength of the magnetic field by the magnetic field lines. Closer they are to each other, stronger the field is. Okay. So if these lines are closer, the more magnetic line will cross that area. Okay. If field is stronger, what will happen? Magnetic field lines will come close to each other, and from this conductor more magnetic line will flow. So the more magnetic flux. So the first thing is magnetic flux is proportional to the what? Magnetic field. Second thing is that magnetic flux is directly proportional to the what? Directly proportional to the area of the conductor or area of the loop. Second thing is magnetic flux is proportional to the area. And if we add them up, we will get phi directly proportional to the b dot a. Okay, it's also depend upon the orientation, or you can say the normal vector of the area. Okay, this normal and the magnetic field direction. If we do what, if we like this vector say is perpendicular to the field, how many electric lines will cross the conductor? On that condition, 0. So it depend upon the what, upon the orientation also. The orientation is like cos theta. So if we do that, it will come like this: b a cos theta. B and A are both vectors. B and A are both vectors. You have heard it right. Area is also a vector quantity. Area is also a vector quantity. Area is also a vector quantity. Yes, area is a vector quantity. Area is a vector quantity. And if we add them up, we will get phi is equal to k p a cos theta. This theta is an angle between normal of the surface and the what, magnetic field. And experimentally we find that k is equal to 1. K is equal to 1. So we get phi is equal to b a cos theta, or you can say phi is equal to b dot a. Phi is equal to b dot a. The way you want to say it, you can say it. Okay, b dot a, or you can say phi is equal to b a cos theta. This is what, this is magnetic flux. This is magnetic flux. Do remember this and make sure this thing will remain in your heart always. Okay, very basic stuff in electromagnetic induction chapter. Very basic stuff. Very basic stuff. After this, yes, we are continuing this. Let's find the unit. Magnetic flux phi. Phi is what? B dot A. Any doubt? No. What is the unit of the magnetic field? Tesla. Area meter square. So the unit of the phi is Tesla meter square. Or you can say is Tesla meter square is equal to the Weaver. Okay. So the unit of the magnetic flux is what? Weaver. Yes, Weaver. Tesla, not company. Tesla is also a unit. Okay, that is named after Nikola Tesla. So Tesla meter square, and unit you can say of phi is Weaver. This is the SI unit. SI unit of phi is Weaver. Or CGS unit. CGS unit is Maxwell, or you can say MX. Okay, one Weaver is equal to 10 raised to 8 Maxwell. 10 raised to 8 Maxwell. So this is the unit of the magnetic flux, Weaver, and in CGS it is Maxwell, or you can say MX, and 1 Weaver is equal to 10 raised to 8 Maxwell. 10 raised to 8 Maxwell. Yes. Oh, neat question time. Okay, question time. Make sure you are sitting with pen and paper. Make sure you are sitting with pen and paper. This is the NEET 2008 question. NEET 2008 question. So make sure you are sitting with what? Pen and paper. Yes, pen and paper. You should have it. The question is very simple. If you do a read, you can solve it. You can solve it. A circular disk of radius. A circular disk of radius 0.2 meter. A circular disk of radius 0.2 meter is placed in a uniform magnetic field. Uniform, we are talking uniformly. Of induction, this 1 by pi WB Weber per meter square in such a way that its axis make an angle 60 degree theta 60 with B. With B, the magnetic flux linked with the disk with this disk is. Okay, we want to find what? We want to find flux. We want to find flux. We want to find flux. Flux is what? Flux is what? Flux is B dot A, or you can say B A cos theta. B is this. B we have given 1 by pi. Okay, 1 by pi. Theta is 60 and area is pi r square. Area is pi r square. A circular disk, we are talking about circular disk, and radius is given. What we have to do now? What we can do? We can solve the question. Okay, what we or what we are going to do? So B is 1 by pi. Area is pi r square. Pi r square. Pi r square. So pi and radius 0.2 meter. 0.2 square cos theta cos 60. Cos 60. Cos 60. Cos 60. Cos 60. This is what we are going to solve. This is what we are going to solve. Can anyone do tell me what is the value of cos 60? Value of cos 60. Okay, 1 by pi. Oh, we can cut pi. We can cut pi. So 0.2 square, 2 by 10, multiply by 2 by 10, and cos 60 value is, I think, 1 by 2. 1 by 2. So we can cut 2, and the answer will be 2 upon 100, and we can say 0.02 Weber. 0.02 Weber. 0.02 Weber, and the correct answer is C. Correct answer is C. No, very easy question. Very easy question. Very easy question. You should know the formula. This, if you know this formula, you can easily solve it. You can easily solve it. You can easily solve it. And now make sure you have subscribed our channel on YouTube. For regular class updates, you should do what? Subscription. Okay, press the subscription button and press the bell icon. That is necessary thing. That is necessary thing. After this, now magnetic flux in a non-uniform field. Okay, in a non-uniform field where B is not constant. What now? B is not constant. B is not constant. So what we can do? We can do integration. When something is not constant, what we usually do? We do the constant thing. So we can write phi integration d phi, and similarly we can write like this: B dot dA. Okay, B dot dA. And this is for what? This is for the non-uniform field. For the non-uniform field where B is not constant throughout, what we do? We do the integration thing. D phi is equal to integration of B dot dA. D is also an what? Vector. Any doubt, my dear friend? Any doubt? I think every doubts are clear. Every doubts are clear, you know. How much in a easy way can I, teach you? After this, special cases. Let's talk about special cases. For the uniform field, this is for the uniform field. This is for the uniform field. We know phi is what? BA cos theta. BA cos theta. Special cases. Special cases depend upon on this theta. Theta can be, you can say, in first case, theta is what? Theta is stroke large eraser, large. Okay, theta is, you can say, 0 degree. What about it? What now? When theta is 0, what will happen? Theta, what is the value of cos 0? The value of cos 0 is what? 1. So theta in this condition will be max. Maximum possible magnetic flux you can have. That will be BA. In this case, when then the magnetic field and the normal vector of the area is on same direction, or you can say parallel. In second case, what can happen? Theta is 90 degree. Theta is 90 degree. What does that mean? What does that mean? So B is like this, and this area vector is like this. Theta 90. In this case, what will happen? We will get theta minimum, and that is what? Cos 90. What is cos 90? Cos 90 is 0. So BA into 0, everything multiplied by 0 will become 0 itself. Everything multiplied by 0 will become 0 itself. So it will become 0. Yes, 0. After this, hello sir. Hello sir. How are you, bro? After this, third, what can happen? Theta can be greater than 90 degree. In this case, what will happen? When theta is greater than 90, phi will be what? Phi will be positive. In this case, okay. When theta is less than 90, okay, and when theta is greater than 90, phi will be negative. Okay, it's depending upon the cos value. Cos positive, then the magnetic flux positive. Cos theta negative, then it is negative. Cos theta 1 equal to 1 in this condition in the first case, then it will be maximum. If cos theta is 0, it will be minimum. It is depending upon the theta, the angle between B and A. Pretty easy stuff. Now let's talk about, I think magnetic flux is clear. What is magnetic flux is clear. Now let's talk about the experiment done by Faraday. Experiment done by Faraday. Okay, what he done? He is taken a magnet. Okay, he is taken a magnet, and magnetics are like this. Okay, north south. If magnet is like this, field lines go from north to south, like this, north to south. Okay, north to south, like this, north to south. Yes, field lines go from north to south, and he has taken a circuit coil, closed coil, and there is a galvanometer. there is a galvanometer here. This is the galvanometer, which can measure the current in the circuit, and do also tell the direction of the current in the circuit Okay, can also do tell the direction of the current and the magnitude of the current. Here is a galvanometer. What he done? He see first. In first case, there is no relative motion. There is no relative motion. In first case. There is no relative motion. Means the velocity of the magnet is what? Is zero. So he sees that there is no current in the circuit. But he got naughty. Yes, very, very naughty. And he moved the magnet slowly towards the circuit. He moved the magnet slowly towards the circuit. And here he sees what? He sees the deflection in this direction. Deflection of the galvanometer. This is the deflection of the galvanometer that Faraday is noting. After this, after he's moving in this direction, in the right direction, he moved in the left direction. He changed the direction. And the deflection of the current is also changed. But he hasn't stopped there. Okay. He again changed the direction. He again sees deflection is in this direction. Okay. After this, what he done? Okay. Moving in this direction. What he done? He again moved the magnet in this direction. Again, move the direction. Again. Do the what? In this direction. He saw. Again, deflection changed. Okay. No. In this, he changed the pole. Okay. Is NS and this is south north. He changed the direction of the poles. After he changed the direction of the pole, he says deflection is in this direction. And what he done in this thing, he increased the velocity. Of the what? Of the magnetic. He is moving right and left. He doubled the speed. And he sought double deflection. Okay. Double deflection, or you can say more deflection. He sought more deflection. Okay. Magic is happening, my dear friend. Magic is happening. Yes, magic is happening. There is no battery connected in the circuit. There is no battery in the circuit. But when he's moving magnet left and right, he's seeing what? The current in the circuit. From where this current is coming from. And he from watching these two things, okay, he done another experiment. Okay, this is the experiment he done. He's taken the two loops. One is bigger loop P, one is loop is Q, and you are watching the loops from this direction. Okay, and Q is connected within a galvanometer, which can measure the current in the circuit. When he saw what? Whenever he closed the circuit, or whenever he open or close the circuit, an induction of current is happening in the circuit. An induction of current is happening in the circuit Q, and with Q there is no battery connected. But 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 despite that there is a current in the what, in the circuit Q, in the circuit Q. So he linked this thing with the magnetic flux. He linked this thing with the magnetic flux. Yes, with the magnetic flux. And he said, whenever there is a change, in magnetic flux in a coil or in a closed loop, whenever there is a change in the what, magnetic flux in a loop, in a closed loop, okay, in a closed loop, there will be always be in what, always will be an electromagnetic induced current. There will always be in what, electromagnetic induced current. And that is happening because of the change of what, magnetic flux in the circuit. That is happening because of the change of magnetic flux in the circuit. Okay, what he said, whenever yes, whenever there is a relative motion, whenever there is a relative motion between a coil and a magnet, an EMF, yes, EMF is induced in the coil, is induced, INDU, induced in the coil. Whenever there is relative motion between a coil and a magnet, an EMF induced in the coil. First statement I have already written here. This is the second statement. Whenever there is relative motion between a coil and magnet, an EMF is induced in the coil. And if it is a closed circuit, and have some resistance, R, and a current will be induced in the coil. Yes. Good afternoon, sir. Good afternoon, Vikesh sir. Tayara coaching. Good morning. Good afternoon. Yes, it's good afternoon. Okay. And this induced EMF, this induced EMF will last as long as the change in magnetic flux is happening. This is the Faraday law. Faraday said this induced EMF lasts as long as the change in the flux is taking place. The change in the magnetic flux taking place, if change is happening in the quantity of the magnetic flux, there will be an EMF. This statement is what? Important. Okay, this statement is important. And second law is the magnitude of the induced EMF. The magnitude of the induced EMF is equal to the rate of change, means del phi of in del t, rate of change in magnetic flux. The induced EMF is equal to the rate of change in magnetic flux, means E is proportional to the del phi by del T. Del phi by del T, if we talk about average current, that will be equal to, we are talking about the magnitude, okay, we are talking about the magnitude, so E average will be, induced EMF will be del phi by del T. And if we talk about the instantaneous EMF, instantaneous, in which we write del phi by del T, del phi by del T. And if we talk about the direction, this is negative, like this, d phi by dt. Okay, this thing is given by Lenz's law. This direction is given by the Lenz's law, and we will do it in next lecture. This is the magnitude we have of the induced EMF in the coil. That is the rate of change in what? Rate of change in of the magnetic flux, And if we talk about the current we have, okay, galvanometer, what we are calculating, we are what we say, measuring the current. We are measuring the current in the circuit. Yes, we are measuring the current in the circuit. If the coil has resistance R, then the induced current will be E by R. Induced current will be E by R. If the coil has the resistance R, then the induced current will be E by R. E by R, or you can say E is del phi by del T into 1 by R. This will be the induced current in the circuit. Del phi by del T multiplied by 1 by R. I think everything is clear. Easy stuff. Easy thing we are doing. So this is the induced current in the circuit. After this, how flux can change? How is happening? Okay, what is flux? B A cos theta. Flux is B A cos theta. For changing this thing, we can change three things. We can change B, we can change A, or we can change the orientation between B and A. Let's see, this is the magnetic field going inside. Okay, this is the direction magnetic field. By the cross, we have the cross magnetic field. And if we change the magnitude of the magnetic field B, what we can have? We can have the induced EMF. We can change the flux. If we can change the B, V is changing. Yes, B is changing. We can write B as like this, like increasing order, like 4t square plus 2t plus 6. If it is increasing with time, or we can write it like this: B is equal to 3 by T. This means this thing is decreasing with time. This magnetic field is decreasing with time, and this magnetic field is increasing with time, like 4t square to 2t plus 6. This field is increasing with time, and this field B is equal to 3 by T is decreasing with time upon 3t. Another thing we can do, we can change this A. We can change the A. In second condition, A is changing. Let's suppose we have a circular coil, and we can decide the rate of the change of radius dr by dt. We can say it is for increasing, we can say this is 4t square changing with time, and for decreasing we can say dr by dt is equal to 3 upon t cube. It is decreasing, so we can change what magnitude of the magnetic field, or we can change the area. Area we can change by what? By changing the radius of the coil. And if it is rectangle, we can change the length or we can change the breadth with respect to time. We can do that. Very simple and easy thing, very simple and easy thing to do. Okay. And last thing we can do, we can change the theta. We can change the theta orientation between B and A. We can change the theta between B and A. Phi is what? Phi is BA cos theta. Phi is what? BA cos theta. B is constant, A is constant. Just rotate this theta with some angular velocity, and we can have what? We can have the change in magnetic flux. We can have the change in magnetic flux. Phi is what? BA cos theta. We can change theta. We can change theta with some like factor 4t square, or increase the speed or decrease the speed. It is upon you that how you wish to change it. It is upon you how you wish to change it, with which omega you are rotating it. So in these three ways, we can change the magnetic flux. We can change the magnetic flux. Easy peasy thing to do. After this, we have question, NEET 2019 question. It's question time. It's a question time. Do read the question. Okay, I am drinking water. So in that time, read the question and try to do the question. Okay. The question is, a 800 turn coil, okay, of effective area, we have area, is kept perpendicular to the magnetic field. Of this magnitude when the coil is rotated by 90 degree around any of the coplanar axis. In this time, the EMF induced in the coil is asking for the what? He's asking for the phi. We want to find phi. Very easy question. NEET 2019 question. We want to find phi, and let's see what is given. We have n is 800. Area, we have area is 0.05 meter square. We have delta t is 0.1 second. We have magnetic field B. Magnetic field is 10 raised to minus 5 Tesla. 10 raised to minus 5 Tesla. These things we have. We want to find phi. Phi is what? Phi is. We have found induced. We want to find induced EMF. So E will be d phi by dt. We want to find the induced EMF in the coil. That is minus phi final minus phi initial upon delta dt in dt. We want to find this. So let's find the phi initial. phi initial we have phi initial will be, we have n coils. This is in B dot A. This is for the one coil, and for all coil this will be NBA. For all the coils this will be NBA. NBA. Okay, this will be NBA cos theta. Cos theta. Initially this current magnetic field. Okay. Initially theta was 0. Initially theta was 0. Theta was 0. Okay. Theta was 0. You can see it. Is keep perpendicular. Effective area kept perpendicular to the magnetic field. Kept perpendicular. This is a magnetic field. This is our coil. So the normal vector will make what? 90-degree angle. Okay. Normal will make the angle 90-degree with it. So phi theta is 0. So n is 800. B 5 into 10 raised to minus 5. 5 into 10 raised to minus 5. Area is 0.05. Area 0.05, and cos 0 is 1. If we solve it, we will get this will become 2 into this. Let's solve it. So this will become 10 raised to minus 3 Weaver. Okay. And final will be, okay, rotated. Now it's rotated by 90-degree. So theta in final condition will be 90-degree. So this will become NBA cos 90, and this thing will become 0. Cos 90 is 0. So we don't have to put this value. Cos 90 is 0, everything 0. So induced EMF will be minus del phi by del T, d phi by dt. So this will become minus 0 minus 2 raised to 10 minus 3 upon dt 0.1. dt is 0.1, I think. 0.1. So we will have E will be minus plus 2 raised to 10 raised to minus 2 volt. 2 raised to minus 2 volt. So E will be 2 raised to minus 2 volt. So the right answer will be A. 2 raised to minus 2 volt means 2 divided by 100, or you can write 0.02 volt. 0.02 volt. Easy question. Yes, easy question. After this, we have another question. Okay. Now we have a flux like this. Flux is given by this 50 E square plus 4. We have the resistance 400 ohm. Okay. And we want to find the current at t equal to 2 seconds. T equal to 2 seconds. Okay. This will be E upon R. And E is what? E is del phi by del T. So we have to differentiate it. So E will be 50T square. So this will 50 into 2T, and this will become 100T. So this is the induced EMF 100T. So the current will be 100T upon 400. upon 400. This means 1 by 4 T. Induced current will be 1 by 4 T. And we want to find this thing on T equal to 2 seconds. At T equal to 2 seconds. So 1 by 4 into 2. Okay. So this thing will become 2 by 4, or you can say 1 by 2 or 0.5 ampere. 1 by 2 or 0.5 ampere, 1 by 2 or 0.5. Option A. Option A. Option A. Option A. Option A. After this, we have NEET question 2010. NEET question 2010. NEET question 2010. A conducting circular loop. Now we have a circular loop in a uniform field. We have a uniform field now. We have a uniform field of magnitude 0.025 Tesla. Plane is perpendicular. Plane is perpendicular to the loop. The radius of the loop is made to shrink at the rate of, we have dr by dt given. Dr by dt is 1 millimeter per second. We want to find the induced EMF. We want to find the induced EMF. We want to find this E. And this is what? d phi by dt. This is d phi by dt. This is d phi by dt. Or you can say this is minus d ba by dt. Okay, let's do here. Phi is what? Phi is b dot a. Ba, in this case theta is 0. So this will become minus d ba by dt. This means E is b minus dA by dt. B dA by dt. Okay. B is this, and we want to find A. dA by dt. Yes. E. We want to find E. Okay. So the induced EMF when the radius is 2 centimeter. We found when the plane perpendicular loop, the radius of the loop is need to shrink at the constant rate 1 millimeter second. The induced EMF when the radius is 2 centimeter. Induced EMF when the radius is 2 centimeter. Radius is 2 centimeter. So dr by dt be given. Now we can find phi ba cos theta. Phi. Let's do this like phi is ba pi r square. B into pi r square. We can do this easily. Okay, we don't have to go like this. BA, and area is pi r square. Angle is 0. B pi r square. And E is d phi by dt. Just differentiate it. We can differentiate. So we can write B pi r square. Okay, d r square by dt. We can do like this. B into pi dr square upon dr into dr by dt. This thing will become 2r. This thing will become 2r. So B pi 2r dr by dt. Induced EMF will be B pi 2r, and dr by dt is 1 millimeter second inverse. Dr by dt is this in SI. Let's put the value. Let's put the value. E will be, E is 0.025. Pi is 22 by 7. 2, and radius is when is 2 centimeter, is 2 centimeter. 2 into 10 raised to minus 2. This minus 3, minus 2, and minus 3. We can add the powers. If we solve it, just don't put the value of pi. Okay, because the answer has pi on it. Because the answer has pi in it. The answer has pi in it. If we solve it, we will get pi and 10 raised to minus 6 volt, or you can say pi microvolt, pi mu b, and the answer is B. Answer is B. Answer is B. Answer is B. Okay. Answer is B. And pretty easy question. Pretty easy question. I should drink some water. Pretty easy question. After this, we have induced charge. What are induced charge? If the current is inducing, that means somewhere charge is also inducing. Okay. Induced EMF is d phi by dt. Induced EMF is d phi by dt, and induced current is, if the coil has a resistance R, this will be E by R. This means 1 by R d phi upon dt. This will be the induced current. And now we know that the current is what? dq by dt. We know this now, current is dq by dt. Current is dq by dt, and the induced current is 1 by R d phi by dt. Equation 1, equation 2. Now we can just match them. So dq by dt is equal to 1 by R d phi by dt. dt cut. So dq induced current will be d phi upon R. Induced current will be d phi upon dr. Or you can say del q will be del phi upon R. Del phi upon del R. Or you can say important. This thing is important. Yes, this thing is important. This thing is pretty important. You should know and have this thing in your heart. Pretty easy and pretty important stuff. After this, in our course, we have 100 plus classes, 90 plus classes, concise and concentrated classes. We have convenient and convenient platform which you can access from everywhere. You can access it from mobile, your laptop, your PC. You can access it from anywhere. You can access from it anywhere from you want to. Okay, you just have what you need. You need some internet, and if you have internet, you can access us from anywhere. Syllabus made from NEET expert. Okay, me, Vishnu sir, and our biology faculty, Pratyaksh sir, made this syllabus concise and concentrated for you. And we have the unique flipped classroom method. First in India, we are introducing this concept first time in India. And if you do study by this method, you have 40% more chances to get your dream college. Flipped classroom method. We have doubt solving practice. That thing is important. Doubt solving is important. We have mentors in our groups. What you have to do, you should if you have any doubt, just send the message. If you have no doubt in any question, just take a picture of the problem you have and send it to the group. We have our Telegram channel, we have our WhatsApp channel, where you can send us what your queries, your doubts, your questions. You can send us in our what groups. So we have live doubt solving practice. Yes, you have heard it right. Live doubt solving practice you can have. After this is our class. What we do, first we will teach you the theory with some questions, and then we will provide you study material that you can read, that what we have taught you. After that, if you have any doubts, what we do, we take webinars in which we solve your all the doubts, the doubts you have and the queries you have in webinars. After this or while doing this, we will give you homework and we do check them. The homework that we have given you. First, we teach you theory, then give you study material, then give you the webinars. Okay. Sir, electromotive force. What is electromotive force? Okay. Let's see, go there, in this thing. Okay. Electromotive force. We have done like this. Let's see, just imagine the thing. Okay, you need the imagination. We have the charges inducing, we have the current, we have the potential. Okay, the potential difference we are creating, it is called what? Electromotive force. Electromotive force. Are we clear? Are you there, my friend? Are you there? Electromotive force. Pretty easy stuff. Okay, you know what is potential, my dear friends? What is potential? Potential difference. It is the same unit as what? Where we are. We need some blank page. Like this. Electromotive force. E, we are talking about the electromotive force. Not this. Okay. Tiger lead out. First read the potential, electromotive potential we have. EMF. Okay. So when we change the magnetic flux, magnetic flux change. Due to the Lenz's law, there will be what? There will be conservation of energy. Because of this, an or you can say there will be an electromotive force induced in the current. Okay, electromagnetic force induced in the current. Okay, it is what EMF is nothing, or you can say this is electric potential difference. Electric potential difference induced. Electric potential difference induced. Okay, are we clear? Are we clear? Are we clear? Okay, this can be done by two ways. Electric potential difference we can create by two ways. Okay, we can create by two ways. One. We can change by changing magnetic field. Changing magnetic field. Electromotive force. This is nothing but the electric potential difference induced. This is nothing but the electric potential difference induced. This is called what? This is called what? This is called electromotive force. Electric potential difference induced. Okay. Where we are. This is electromotive motive force induced. Now we do also check your homework. Okay. And we check them also. This is how our NEET plan look like. We have light, smart, and proficient. Light, smart, proficient. In light, smart, proficient, we have all this force. We have interactive live classes. We have structures course and PDFs. We have live doubt solving. We have physical notes. We have all these four things. In all light, smart, professional. In smart, we have three things more: one-to-one mentorship, live doubt solving, mock test regularly. Mentorship is important. Okay, they show you the way that how you should do your NEET preparation. Live doubt solving, that thing is important. Okay, I have solved the Tiger Lee. Okay, Tiger Lee. He asked what is electromotive force. Electromotive force is defined as the electric potential difference. Okay, produced by the changing magnetic field. Okay, and in proficient we have additional special courses. That if you need motivation or something like that, we have in proficient. So we have three plans: light, smart, proficient. And don't forget, we have a 3,000 rupees. What discount that is going right now, that you have to apply NEET PHY30, and you can have 3,000 rupees discount and can get the plan in 299 rupees only. Okay, yes, you heard it right. 3,000 rupees discount. You can have a plan that costs 3,299 rupees will cost you what? 299 rupees. Okay, 3,000 rupees discount. You just have to apply NEET PHY30 34 3,000 rupees discount. We have two channels. We have one channel where we share our files, our notifications, our prizes, our giveaways. We do in this channel. Okay, this is Altedemy NEET channel, where we give useful files. You do giveaways and do the notifications, do the announcements of the hefty discounts that you can have. And this is our channel for the NEET aspirants, where we do what? Where we give you, where I am in the group, Vishwajit sir also is in the group. This is a Telegram channel link. So in this channel we have discussion with the students. Me, Vishu sir, Pratyaksh, our mentors are all in this group. So you can personally message us, chat with us, and do the discussion. We are all there for you. So let's see you in the next lectures. Till then, take care of yourselves and I hope you are all studying and doing very good. Bye bye.